Alright, you're wondering, what am I going to use that RC channel MUX for? Now, right here, you can see I just got it set up to a servo, and it's reading 6 channels and outputting the channels one by one from this. Now, I can, like, move, and it'll take a different position on that, and move this one. It'll take a different position on that one, you know, so on and so forth. Flip the switch, and it'll take a different position on that one. Move this up, you know, it's reading all of these different positions, and outputting them to the one servo. With the robot, I'm actually only going to have a couple servos on there. Most of the feed coming from this, I need it for the numerical base, for moving the robot with the PID controller and all that. So that was the whole reason behind me making it and creating that 8-channel MUX. So now this project is to show you how to actually use the data, let's say something like this. So you can have 6 different channels and maybe time it for each one or use it somehow, but like I said, I'm only going to have 1 or 2, and it's not for servo control that I made it, but it can be adapted for it. Alright, so let me go ahead and get this made, and again, subscribe, enjoy, don't like, don't care. Have a good day. Use the RC channel MUX video to get this portion set up. Alright, so one of your first steps is to get your binary decoder set up. You're using the same input that is changing the read. Now it outputs all of those 0 through 5 pins over to your analog values. Now the pulse for it to switch on is sent down over to the remember analog value, and it's also sent through the RC servo meter and then the RC mapping. Down here is where the signals are combined and remembered. Every time that signal comes up for that specific channel, it'll go to remember, and then every time the clock pulse goes off, right now every half a second, it will recall it, which will remember, and then it goes around in a loop and updates and outputs all of those values to the text output that we were looking at before. So this is the kind of project you're definitely going to want to go into, knowing exactly what you're going to need, how many channels you're going to use. Like I said, this is slowed way down just so that we can see actually what it is doing. Like I said before, also I got it up to 120 Hertz, which was updating all 6 channels 20 times a second. That was at 120 Hertz, and it was stable. Now the text output was slowing it down a little bit, so it was kind of jumbling up there. But if you were to get rid of all that text output and stuff and just use the bare basic update the channels and use the remember analog value and all that, you shouldn't have any problems. And if anyone has any hints or tips as to how to make this a little bit better, please put a posting in the video link before. You know, you can subscribe to my Google Plus channel, my YouTube channel. I've got quite a few that are going with this robot, and another thing, like I said, this is only one part of many. So there are so many different pieces of this robot that I need the videos for, so I decided every part that I have to make for the balancing robot, I'm going to make a video for it. So hopefully somebody like you can use it, and also remember that VISUINO is using way less memory, it's working faster, it's working smoother. They're adding updated components all the time, so you should try checking it out. And I do also think that on this one I'm going to include the VISUINO build file so that you can actually open it up in VISUINO and look at it and see how it's actually using the different channel selections and using the binary decoder chip, the MUX and DeMUX, or something like that. Anyway, like, don't care, subscribe, don't subscribe. Hope you got something out of the video. Have a great day.